yolk sac and then migrate to the testes.
So when you say yolk sac, when you compare it to an egg, do you mean the yellow part or the white part?
Yellow.
The yellow, okay.
Yeah. It's not
So
big
like
like
the-
in an egg.
Isn't that like the nucleus?
No, no, no. Oh, I love it when my kids used to take biology in high school. You know, these biology teachers make such outrageous statements. And I sit there and grit my teeth, decide whether or not it's important enough to correct it or just let it go, you know. So my kid came home one day and said what she said. You know, I was talking, and the teacher told us that the egg was this one cell. That's true, it is. And the yolk was the nucleus. And I'm going, no, it's not. It is one cell. It's a big cell. The actual nucleus and cell, you know, mitochondria, all those parts, are a little spot at the top of the egg. Just a little spot. All of that is a food resource for that developing spot. But it's a nice analogy. If you say, look, it's an analogy, this would be the nucleus, but sometimes they think it's the actual nucleus. Okay, so derived from the yolk sac. Now, it's diploid. When I say diploid, does everybody know what I mean? Yes?
Two.
No. Okay. So, you have 46 chromosomes. 23 came from daddy, and 23 came from mommy. Okay? Together, 46. So, daddy gave you one set. The chromosomes are numbered, 1 through 23. Gave you one number 1, one number 2, one number 3, one number 4, one number 5. Mama gave you one set. A number 1, a number 2, a number 3, a number 4, a number 5. Together, you have how many sets? 2. Mommy gave you one, daddy gave you one. They each gave you a number 1, they each gave you a number 2, they each gave you a number 3, right? So you have 2 sets. 1 through 23 from daddy, 1 through 23 from mommy. You have 2 sets. If you have 2 sets of chromosomes, you are diploid. And the abbreviation for that is 2N. 2N means diploid. Yeah.
So haploid would be just one set?
Yeah. And so what we have to do in making sperm is we have to cut the number of chromosomes down to 23. And not just any old way. Because I can cut the chromosomes down to 23 by having 2 number 1s. Right? I just eliminate the number 2. So I've got to have a very specific set with 1 number 1, 1 number 2, 1 number 3, 1 number 4. Okay? So sperm cells are 1N, meaning what?
Haploid.
Haploid or 1 set. What if something is 3N? It has how many sets?
Triploid.
3. And plants are strange this way. Plants have all kinds of... It's very difficult for us to hybridize, okay? But plants do it all the time. So, 2N means you have 2 sets. Same as your liver, your kidney, everything else. But we got to try and cut this down to 1N. Now, in males, this cell becomes functional at puberty. Okay? So, what age is puberty for males? 12, 13? I don't know. Something. Somewhere around 12, 13, 14. Okay. Now, this cell is going to divide by mitosis. Everybody know what mitosis is?
Mm-hmm.
If you don't know, say no. It's okay. Okay. So mitosis is simply a cell division in which the 2 daughter cells are going to have what? Same number of chromosomes as the parent cell. Okay? So that's how your liver divides, or your intestine, or your skin. The daughter cells are going to have the same number of chromosomes. Okay? So, in that division, one of the daughter cells is going to be another spermatogonium, and the other one, both of them 2N, but the other one's going to be what we call a primary spermatocyte. Now, notice, when this cell divides into these two, does this one exist anymore?
Yeah.
Yes?
What is it, both places?
When that cell divides, it doesn't exist anymore, does it? It became this one and this one. That is, I divided this sucker in half, and half of it went this way, and half of it went that way. So the mother cell ceases to exist once it divides. But in this case, notice when that mother cell divides, it produces another sperm mother cell, and the other daughter is a primary spermatocyte. Both of them are diploid. Both of them have the same number of chromosomes as the parent. Yeah.
So what's the difference between the two then? The primary
These two?
Yeah.
This one is going to go on and act just like this one. And this is going to go on for the rest of your life. Okay? This one's going to do some very different things. Now, what makes, how to choose this one first? I mean, how was that decision made? Will you be the spermatogonium and I'll be the primary? I don't know.
So they're
I don't know
identical.
how that decision is made, but
They're identical, but their purposes are different.
they have different functions. Okay, let's see what happens here. Oh, what happened there? Okay, so I'm just picking up, what I'm doing is picking up from here. Okay, so here's my spermatogonium. It's divided into spermatogonium and a primary spermatocyte. Let's talk about this one. Okay? It's diploid, as we can see. It begins the process of meiosis. Now remember, the process of meiosis is where the daughter cells are going to have what? Half the number of chromosomes. Half the number. And it's going to divide twice. That first division is called the reductional division. Okay? And it goes through a number of phases to get there. It goes through something called prophase 1, metaphase 1, anaphase 1, telophase 1. Okay? And then we get the daughter cells, which are secondary spermatocytes. Notice they're equal size, so we say it's an equal division. And this should give it away. Reductional means we're going to cut the chromosomes in half. Okay? So we have now a 1N and a 1N because these are, okay, because they're half. They're one set. We've gone from two sets to one set. Is everybody following me? Okay, so let's pick it up again. Here we're interested in right here because we already talked about this one, talked about that one. Let's talk about this one. Okay, secondary spermatocyte now. Okay, it's haploid. These two cells are going to go through equational or equatorial, goes by a couple of names, division. Question over here.
Some of these things on there are not on the outline.
I added this.
Okay, just checking.
Yeah, I gotta add it to the outline. I forgot.
Yeah, there's-
I wasn't gonna go through it once, and then I thought, no, I better go through it. So I had to write.
Okay.
So you need to look at this.
Okay.
That's why I said when you're studying, you gotta look at this, plus you gotta look at the outline. If there's some differences, then you need to fix it. You're absolutely right. Well, thank you for bringing it up, because you need to. Okay? Okay, so this is an equational division. Okay? And this is where we go through prophase 2, metaphase 2, anaphase 2, telophase 2. Now, I'm not going to take time to go through and tell you what happens in all those. Okay? If you want to know, you can look at it. but we're going to come back and mention these here when we do the females. Okay? The daughter cells, again, equal size. They're known as spermatids. Okay? Equal division. And they are also one end. So notice in this process, we start with one cell, we end up with 4 cells. And we started at 2 ends, and we end up with 1 end. Took us 2 divisions to do that. Okay, now let's take a look at these spermatids. They're haploid. They go through a process called spermiogenesis, which is just a fancy word that means maturation. And what it means is they simply get their tails and lose a lot of cytoplasm. Okay. And a single one would be spermatozoan. Z-O-A-N, plural would be spermatozoa. The term spermiation simply means the process of moving into the tube. Remember, those Sertoli cells are kind of directing the process, and the actual process of being released to the tube, the middle of the tube is spermiation. Okay, everybody with me? Not tough. Notice that the first division up here is mitotic. And then beginning here with the primary spermatocyte, it's meiotic. I'm cutting the number of chromosomes in half.
So isn't the 2n to the 1n meiotic, but then the 1n to the 1n is mitotic again?
Yeah, why'd you ask that? Okay, what's the definition of mitotic? Daughter cells have the same number of chromosomes as the parent. What's meiotic? Daughter cells have half the number of chromosomes. Okay. So, in my opinion, this is a meiotic process, this one is a mitotic process. Okay? But I promise you, if you say it that way on any exam, you're going to miss it.
Oh, really? So they're both...
I spent 2 hours arguing with another PhD who said, no, this was meiotic, and I'm going to, it has the same definition, you know?
Yeah.
And we literally spent 2 arguing. We didn't convince each other.
Did any bones break? I'm just checking.
But I fully agree with what you say.
Because that's what you have it in your notes, and that makes sense to me.
What did I say in my notes? Essentially...
your opinion.
Yeah. I mean, it fits the definition, so I don't know why. But if you go to any textbook, any place, they'll never refer to that as a mitotic division.
Okay.
Even though it fits the definition. You know. And so what you want to do in talking about these 2 divisions, you want to talk about what? Reductional versus equational or whatnot. Yeah.
Is the secondary spermatocyte kind of like, is it like halfway through? The complete end process is spermatid, right? So maybe when they say meiotic division, it's just talking about going from the primary spermatocyte to the spermatid.
I don't know. It's just one of those things that's hard to figure out.
What's the difference between the secondary and the spermatid? They're both
Between here and here?
Doesn't it like accomplish the purpose to get haploid?
Oh, why does this one divide again?
Yeah, because it's already haploid.
Okay. I don't think I go over it here. To understand that, you have to understand that prophase 1, metaphase 1, anaphase 1. Okay. So, in mitosis, if I'm going to divide, okay, and I'm going to have my daughter cells having the same number, I got to make a copy.